Okay, to help you guys out with the homework, I am going to be doing a little video here. And I'm going to be going through this stuff fast. So passenger train, we're going to call that the P train, is going at a speed of 60 miles per hour. So I'm going to put the rate, the time, and the distance right there. 60 for the rate. Freight train, we'll call that the F train, is going 40. Passenger train travels the same distance in 1.5 hours less time than the freight train. So the freight train is what we'll call T, and then the passenger train is what we'll call T minus 1.5. 1.5 less than the freight. How long does each train take to make the trip? So same distance. What we know is that whatever we get here for these two spots, they're going to be set up equal to each other. The distance is equal to the rate times the time. So we'll have 60 times T minus 1.5, and then here we have 40 times T. Set this up equal to this, so we have 60 times T minus 1.5 equals 40 times T, which is 40T. I'm going to distribute 60 to both terms. 60T minus 90 equals 40T. If I subtract 60 from both sides, this crosses off. I still have negative 90 equals 40 minus 60 is negative 20T. And then always divide by the number in front of the variable. Divide by 20 so that you can get rid of that number in front of the variable, and you have T equals negative 90 over 20, or 4.5. That's how long it takes each train to make the trip. Actually, that's just the freight train. So the passenger train would be 1.5 less, which would be equal to 3 hours. So the passenger train would be 3 hours, and the freight train is 4.5. Number 2, Lois rode her bike to visit a friend. She traveled at 10 miles per hour. So I'm going to say Lois, rate, time, distance. She traveled at 10 miles per hour while she was car traveling. Okay, so basically it began to rain, so her friend drove her back home. So I'm going to say, actually, instead of Lois, we're going to call that going on bike, going by bike. And then on the way home, it's going to be a car. What we know is that it's going to be the same distance either way, to and from home. Now, the time is what changes. Lois took 1.5 hours longer to go to her friend's house. That means when she was on the bike, than when it took her to go home. So we're going to call going home time T. It's unknown, but going there is going to be T plus 1.5. So the distance would be equal to R times the T, 10 times T plus 1.5, and then R times T is 25T. We know they have to be the same distance going home and going to the place. So we take 10 times T plus 1.5, and that equals 25T. Take 10 times T, which is 10T. 10 times 1.5 is 15. That equals 25T. Subtract 10T from both sides, so I can have all the numbers on one side and all the terms with a letter on the other. Divide by 15, the number in front of the variable. Either way, it cancels. Anything divided by itself is 1. So I get T equals 1 hour. But that's not what we were asking. How many hours did it take Lois to ride to her friend's house? Ride to her friend's house is T plus 1.5. So add 1.5 and you get 2.5 hours. May rides her bike the same distance that Leah walks. So I'm going to say May, Leah, rate, time, distance. May rides her bike 10 kilometers per hour faster than Leah walks. So if Leah is walking at a certain rate, then May is riding 10 more. 10 miles per hour, kilometers per hour faster. If it takes May 1 hour and Leah 3 hours to travel the same distance, how fast does each travel? So we say rate times time. R plus 10 times 1 is just R plus 10. R times 3 is 3R. Set them up equal to each other. So R plus 10 equals 3R. Subtract an R. Remember, this is just 1R. Cancel it over here. You have 10 equals 2R. Divide by 2, and you get R equals 5. So Leah is going 5 miles per hour, and then May is going 10 more than that. So May is going 15 kilometers per hour. Length of a rectangle is 4 inches greater than the width. Right away I'm going to say length equals the width plus 4. The perimeter of a rectangle is 24 inches. And what I know is that if I have a rectangle, I have 2 lengths and 2 widths. So the perimeter is equal to the length plus the width plus the length plus the width. Now, perimeter, we're given 24, so I'm going to substitute that in. Length, we're told that it's 4 inches greater than the width. So in place of the L's here, I'm going to put W plus 4. In place of the W's, I can't put anything. We're just solving this in terms of W. So I have W plus 4 plus W plus W plus 4 plus W, all equaling 24. So that is 1, 2, 3, 4 W's. And then adding 4 more is adding 8. Subtract 8 from both sides. I get 4W equals 16. Divide by 4, divide by 4. Then the width is 4. But we know the length is 4 inches greater. So length equals 4 plus 4, which equals 8. 8 and 4 are the dimensions. The length of a rectangle is twice the width. The perimeter is 48 inches, so find the dimensions of the rectangle. So I'm going to change this view right here so I have a little bit more room. Length of the rectangle is twice the width. So length equals 2W. The perimeter is 48. I'm going to use the same formula. P equals length plus width plus length plus width. Perimeter 48. L is actually 2W. Bring down the W. 2w, bring down the w. Now I have 2 plus 1 more is 3, plus 2 more is 5, plus 1 more is 6. So I have 48 is equal to 6w. If you were to divide by 6 on both sides, you would get w equals 8, width of 8 inches. Now the length is twice the width, so that would be 2 times 8, which equals 16 inches. So the dimensions would be 8 inches by 16. A car leaves the house at a rate of 60 miles per hour. At the same time, another car leaves the same house in the opposite direction at 50 miles per hour. So we're going to call the first one car A. The second one is car B. And rate, time, distance. Car A is going 60. Car B is going 50. At what time will the cars be 330 miles apart? So we don't know the time, but they're traveling at the same time. So they're going to have the same time right here. And this distance would be 60t. This would be 50t. And what we know is that if a car is starting right here, it's going 50. Let's say it goes that distance in a certain amount of time. Then another car is going 60. It's going a little bit further. You can tell this one's further away from the starting point than this one because it was going faster. So this distance would be 60 times whatever time, and this distance would be 50 times whatever time. We want the total distance between them to be 330 miles apart. Now what you'd say is that 50t, this distance, plus 60t, this distance, represents the whole, which is 330. Put the like terms together, you have 110t equals 330, divide by 110, and t equals 3. And I don't know why I did that. I didn't let the ink dry, I guess. Train leaves the station at 6, going west at 80 miles per hour on the parallel track. The second train leaves the station 3 hours later, traveling west at 100. At what time will the second train catch up with the first? So basically, at what time will the distances be equal? So we'll call the first one train A, and we know that's going 80 miles per hour. Second one, train B, is 100 miles per hour. And the second one leaves 3 hours later. So that means that if train A has a certain time, then let's say maybe 10 hours on the tracks, then train B would be 7 because it's 3 hours less than train A. Distance is rate times time, so 80t. Rate times time, 100. Times t minus 3. We want to know when will these distances be equal, when will train B catch up to train A. So we take 80t and we say it's equal to 100 times t minus 3. Distribute the 100, you get 100t. Distribute the 100 to the negative 3, you get negative 300. And that equals 80t. Subtract 100 from both 100t from both sides. I get negative 20t. Divide by the number in front of the variable, always. So that crosses off, and you get t equals whatever negative 300 over negative 20 equals, which is the same as negative 30 over negative 2, which is the same as 15. Is that what it asks for? At what time will the second train catch up with the first? What time? So, the first train, A, is leaving at 6, and we solve for t. So that's hours after 6 p.m. So we have 15. So 6 p.m. plus 12 hours would equal 6 a.m. But we're not only adding 12, we're also adding 3 more hours for a total of 15. So 6 a.m. plus 3 hours is 9 a.m. Make sure you read the directions. At what time? It takes 1 hour longer to fly to St. Paul at 200 miles per hour than it does to return at 250 miles per hour. So, to and from. Either way, if you're starting at the same point and ending at the same point, it's going to be the same distance both ways. So, flying to, you go 200 miles per hour. Flying from or returning is 250. And I wrote these wrong. Let me fix this. So we have rate, time, distance. And then it says 1 hour longer to fly to St. Paul than it does to return. So returning, we don't know how long, we'll just call it t, but going to is 1 hour longer than t. So the distance is the rate times time, 200 times t plus 1, and then 250 times t. Same distance, so they need to be set up. 200 t plus 1 equals 250 t. Distribute. Anytime you see parentheses, distribute when we're solving these. So we have 200 t plus 200 equals 250 t. I'm going to subtract 200 t from both sides. So I have these crossing off. 200 equals 50t. Divide by the number in front of the variable, and I get t. Sorry guys, I'm tired. T is equal to 4. Now, is that what it asks? How far away is St. Paul? So if I have t equals 4 and that the distance to St. Paul is 250 t, so I take 250 and I plug in 4 for my t, so I'm taking 250 and multiplying by 4, and that equals 1,000 miles away. Three consecutive integers whose sum is 126. I believe we did this in class, but I will do this again. Consecutive integers. If you start with some number, the next one would be n plus 1 because one more than the previous, and then the third one would be n plus 2. All three of these numbers, when you add them together, need to be equal to 126. So I have n, that's 3 n's, plus 1 plus 2 more is 3, is 126. Subtract 3, 3n equals 123, divide by 3. And then 123 divided by 3 is 41. So n is 41, n plus 1 is 42, and n plus 2 is 43. Those are my 3 consecutive integers. Okay, so 4 consecutive odd integers. So an example of that would be like 1, 3, 5, and 7. Odd integers that are consecutive. So if 1 is our first number, then 3 is our second number, but we have to add 2 to the original one to get to 3. Then to get to the next one, 5, I had to take the original number and add 4. Then for the third consecutive odd integer, I had to take whatever I had first, which was 1 in this case, and add 6. Now it didn't have to be those numbers. Could be any numbers. It would work for anything. Let's say hang on a second, you gotta get rid of this. Let's say that it was 23, add 2, you get 25, then 27, then 29. Those are consecutive odd integers. But those aren't it. We're looking for the sum to be 216. So I'm adding n plus 2 plus n plus 4 plus n plus 6. They all have to equal 216. 1, 2, 3, 4 n's. Add 2 plus 6 more, adding 8 equals 216. Subtract 8 is 208. Divide by 4, divide by 4, and equals 208 divided by 4, which equals 52. So n plus 2, so that's not right. Let's see where I made my mistake. Must have made it somewhere in the addition. Oh, I forgot a 4 right there. So this is not actually, so we got 2 plus 6 is 8 plus 4 more is actually 12. Let me fix this. Subtract 12. We get 204. 4n equals 204. Divide by 4. Divide by 4. I get n is equal to 51. Then n plus 2 is equal to 53. And it would be 55. Then 57. Consecutive odd integers. The length of a rectangle is 1/4 its width. The perimeter of the rectangle is 60 centimeters. Find the dimensions of the rectangle. So, length is equal to 1/4 of its width. So, 1/4 times W. Perimeter equals 60. So, I'm going to say perimeter equals length plus width plus length plus width. Perimeter is 60. Length is 1/4 width. Bring down the width, and then bring down L is 1/4 width. Bring down the width. Good. Now if I have one W plus another one, that's 2, and then these two added up is half of a W, so I have 2.5 W, or 2.5 W equals 60. Divide by 2.5, and I get W equals 24. So that's the width. Now the length is equal to 1/4 of W, which is 1/4 of 24, which equals 6. So the dimensions are 24 by 6. Chris and Tom leave their home traveling in opposite directions on a straight road. Chris drives 30 miles per hour faster than Tom. So, here we go. So, rates, time, distance. Chris drives 30 miles per hour faster than Tom. So, if Tom is going a rate of R, Chris is going R plus 30. 4 hours. They are 440 miles apart. Find each of their rates. So, they both travel for 4 hours. We don't know individually what their distances are, but we know that the rate times the time equals the distance. So, we have 4 times R plus 30 right here, and then 4 times R is just 4R. And what we know is that if this is Chris is going faster, so he's going to go further. Tom is going a little bit slower, so he's not going to go as far. But this distance is 4 times R plus 30. This one is 4R. And we had a previous one that looks pretty similar. The total distance between them is 440. So that means the sum of their distances is 440. So 4R plus 30 plus 4R. 4R plus 30 comes from this section, or right here. 4R is the distance that Tom goes, and equal to 440. From there, it's just algebra. 4 times R is 4R. 4 times 30 is 120, plus another 4R equals 440. 4R plus 4R is 8R, plus 120 equals 440. Subtract 120, I get 320 equals 8R. Divide by 8, and I get R equals 40. Each of their rates, well, the R would be for Tom, so he's going 40, and then 40 plus 30 is 70. Bus traveling at an average rate of 30 miles per hour left the city at 10:30. A car following the bus at 50 miles per hour left the city at noon. At what time did the car catch up with the bus? So, I have a bus that's going 30 miles per hour. And then I have a car going 50. So basically, the bus, it goes so far, the car leaves a little bit later, but it has to follow the same distance. At what time are they going to have they gone the same distance? What we know is that however long the bus has been on the road, we'll call it T, the car left at noon, so that's 12, which is an hour and a half later than the bus, meaning that it has been on the road an hour and a half less time than the bus. Now we want to know when their distances will be equal. So the distance for this one is 30 times t is 30t. Distance for this one is 50 times t minus 1.5. And when will the distances be equal? 30t equals 50 times t minus 1.5. 50 times t is 50t. 50 times negative 1.5 is negative 75. That all equals 30t. Subtract 50t from both sides to get all of the terms with t's in them to one side. 30t minus 50t is negative 20t. The 50t's cancel out and I just have negative 75. Divide by negative 20. And I get this canceling and t equaling 3.75. Wait, what time did the car catch up with the bus? So t is the hours after the bus left, which would be after 10:30. So 3.75, 0.75 of an hour is like 45 minutes. So this is 3 hours and 45 minutes after it left. So 10:30 is when it started, and then we're adding 3 hours and 45 minutes. Going 10, 11, 12, 1, so 10:30, 11:30, 12:30, 1:30, that's 3 hours, and then add another 45 minutes, and you are at 2:15 p.m. Okay, so the sum of two consecutive integers is negative 27. So some number, and then it's plus 1. The sum of those two numbers, this one and this one, is negative 27. Let's figure out what they are. N plus n is 2n minus or plus 1 equals negative 27. Subtract 1, 2n equals negative 28. Divide by 2, n equals negative 14. Consecutive, well, if n equals negative 14, n plus 1 equals negative 13. Train A leaves the station traveling at 48 kilometers per hour. So every single time we're doing this, rate, time, distance. Train A going 48 kilometers per hour. 4 hours later, train B leaves the same station traveling at the same direction, 68 kilometers per hour. B, 68. But it's 4 hours later. So, however long train A has been on the tracks, train B will be 4 hours less. And how many hours did it take for train B to catch up with train A? Train leaves station, goes so far. Train B leaves later, catches up. Same distance. Now train A's distance is 48t. Train B's distance is 68 times t minus 4. When will these distances be equal? Well, let's see. 48t equals 68t minus 4. 68 times t is 68t. 68 times negative 4 is negative 272. Subtract 68t from both sides to get all the terms with letters to one side. So I have negative 20t equals negative 272. Divide by negative 20. Divide by negative 20. T equals 13.6. What did they ask for? And how many hours did it take for train B to catch up with train A? So, if train A has been on the tracks 13.6 hours, train B is T minus 4, so that same distance, 13.6 minus 4 equals 9.6 hours. And that is it, boys and girls.